Oké, welke is 1? Welke is 2? Oh, net andersom.
We will manually control the settings by the controller.
Our flaps. We got our aileron. We got our valve system.
Which one?
Okay, very exciting. Our Harrier needs its landing gear. So in this video we're going to work on the landing gear and I'm going to show you guys how to tune the KK2 board, connect the KK2 board, and I will probably try to teach you how the KK2 works and how to see how the reaction controls react on the KK2 board and how to tune this with the PID settings. So hopefully at the end of this video we're going to make a first vertical takeoff test. I'm really looking forward for this one, guys. So let's start immediately with adding the landing gears. Okay, meanwhile, compared to the last video from last week's video, I've added the ESCs. Also quite nice from AliExpress that I ordered some cooling ribs to cool down these ESCs for the big front motor. Same for the back EDF. So this is all wired up. I need to weld some extra wires still for the tail EDF, which I can't wait to test it out. So, but first for now, I'm printing some parts with the bamboo lap, which is actually a tube which will fit inside with the spring. And then we can add the wheels. So I'm going to add these wheels also to stay in the green color. Yeah, let's start with some easy work, and which is cutting the carbon tubes to add the front wheel. For the main landing gear, I'm going to add this easy part with a spring with 2 wheels on it. Okay, let's proceed. Okay, the front wheel is on and it looks epic and it feels quite solid. Because I want to do a takeoff on grass and do a taxi test, high speed on grass. So yeah, this will hold. Crazy. So there will be also 9 kilo servo, which will turn this wheel for steering. So let's move on with the main landing gear, and then it's coming really to life. This model, epic. You cannot even see that it's printed, and the suspension is quite well. Epic. Wow. Wow, wow, wow. It's looking epic, guys. Look at it. So, yeah, what to do next? So let's continue with the wiring actually. Also, the main wing needs some wiring for the flaps. It needs also the control of those connection point for the flaps and also the wiring. And to make it more easy this time, I'm going to use this big connector. Thank you, Live, for this beautiful tip. So we can put a lot of servos on this connector and even to power up even EDFs. But this is for next time. So let's continue wiring and prepare it to configure it for the KK2 board. Okay, guys. So I'm really happy with the result of the Harrier. Also the landing gear looks really pretty awesome. There's also one other airplane which is a lot of common, which is the Boeing X-32. We will also launch this on RC Jet Print. And also she needs a landing gear. And look how it looks already. Awesome, isn't it? So let's add some main landing gears there as well, quickly. And then continue with the KK2 board. But for now it's a nice moment to give a podium to PCBWay, which is our biggest supporter for this channel.
This video is sponsored by PCBWay. PCBWay provides custom PCB services, but they also offer 3D printing, CNC machining, sheet fabrication and many more. We use CNC and also 3D printing to make our projects. Mostly I use PCBWay to CNC cut aluminium parts for the F-35 landing gear. At PCBWay you can easily upload your file, select the material that you want and get a quote in less than 24 hours. Check them out at PCBWay.com, and let's go back to our video.
Okay guys, long day ahead. Alright, so today we're going to work on the Harrier. And the goal is actually to fix the landing gear on the main wing. And we're going to tune the KK2 board. Hopefully we can take out the settings from this KK2 board by USB. Implement it and download it in the new KK2 board. We need also to flash the new KK2 board. And while installing, we can also work on the X32 Boeing. Also, this model will give some attention in this video. It would be nice if we can take her off at the end of this video. So make sure to subscribe, like, and turn on that notification bell if you won't miss any new videos from this channel. So I will do my best. And thank you so much for all the nice comments from you guys. I really love to read them. Alright, now it's the idea to download, or how you say it, yeah, to download the settings to the computer and upload it back again into the new KK2 board, because I really like those settings, and I will explain later how to tune it without those EDFs. So it's downloading. Awesome. And now I get all my settings and outputs for this Harrier model. Let's check it out. Yes, these are the settings. Nice. Okay, let's save them. Alright, so connected to the new Harrier. Now we need to flash it. I'm going to put or install OpenArrow VTOL 1.6. Make sure to, the controller must be the correct one, or else you got some problems later on. So I'm going to choose for OpenArrow VTOL 1.6, which is the latest for a few years ago. And now we're going to write the setup, or actually the firmware, to the KK2 board. So this will take a while. So back to this program. Then we're going to go to my settings menu, and then we say save to KK2 board. Alright, the fuselage is finished with all wires. Everything is connected. So I would say let's move on with the wing. And perhaps we can do a functional test. Looking forward. Okay, our wing needs some servos. So I'm going to use the DSO6 from Char and the DSO9. So I need, let's see, DSO6. Which I find 1.8 kilos of torque, and we need the DSO9 for the big flaps. They are 9 kilos, they can hold 9 kilos. So let's use these. And I need another one, of course, because we need 4 servos. Okay, let's install them. Okay. So we are going to fit the canopy. It starts really to come to life, isn't it? Okay. Super cool. Okay guys, I also installed the upper flaps, which closes the flap really nicely. Just epic. I cannot wait to test her. So we're still working on the landing gears for the wheels. So parts are now prepared. And now waiting for the bamboo lap when the parts arrive, and also those scissor parts. Yep. Almost guys, almost. Woohoo! And here we got our first prototype landing gear with suspension. Just epic. So now I need to print the other side, and we are close to our first hover test. Let's see. Wow, she is standing on her legs for the first time. Epic, epic, epic. Unfortunately, it's now pretty dark outside and it's getting really cold. So maybe tomorrow we can do a first functional hover test. But she is looking stunning. So let's do a quick test. We got our flaps. We got our aileron. We got our valve system, which reacts actually on the gyro. Pitch. And our yaw momentum. And our nozzles. Cool. And tomorrow I'll add the nose gear servo. Wow, epic. Oké, welke is 1? Welke is 2? Oh, net andersom. Okay guys, we got version number 1 with the EDFs in the wing. And Julia is demonstrating, of course. And this is version number 2 with the rolling valves and also with the jaw valve system. So let me know in the comments which one is cooler. Julia, you are cooler. Awesome. Dream came true. Okay guys, good morning. Another day. This is looking cool, right? So we're going to go for our next test before we finish the model. We need to do a thrust test to see if it can take off. I have my doubts because yesterday evening I did a throttle test and it was just running 100 amps. So let's test her first. Okay guys, we got full battery. We got power. So let's do first test, 50 volts, but with a weaker tubular. Let's test. Okay. Well, what you have just witnessed is ground effect. So the Schuebler 600 wasn't able to take off and escape actually the ground effects. It's still unclear why we are at 110, 115 amps. So we're still missing around 1000 watts of power to take off the model or to escape ground effect. But let's be positive. I really liked that the jaw momentum was performing quite well. Jaw was good. The aileron was also quite nice, but because we didn't have enough thrust to escape ground effect, this interferes also with the pressure in the ailerons. So they were behaving, but not that strong enough. So we need more pressure from the Schuebler. So we can try to test another ESC, or we can swap the motors from version 1. We swap this version 1 motor to version 2 because this has a 650 kV motor, and according to the data sheet with 50 volts it should pull around 12 kilos. And this one with the 600 kV engine inside, it should go around 10 kilos. So we can win this extra 2 kilos to take off this model, because this one is even more lightweight compared to the version 1. Okay guys, to be honest with you, I will need to show you some data. So I took out the Schuebler, which is quite easy. It's designed for it to swap it. So we're going to search where is my missing 2.5 kilos actually. Because yeah, with this weight it should take off, and this should push 10 kilos according to the data sheet. So when we look at the data sheet, so this is the one which is in version 1 with 50 volts. We should get 180 amps and thrust around 12.5 kilos. And when we go to our setup, we got 50 volts. I'm charging the batteries. Current draw should be around 125, 130, and then we should get 10 kilos of thrust out of it. Oh, sorry, this is the correct data sheet. So the same data sheet, 130 amps, slightly under 10 kilos, 50 volts. So let's test that in the setup. But first, I need some full batteries. Okay, this is the setup. Telemetry 3 says 50 volts. To see it, if the test setup is 5, I can push it to 12 kilos safely. So let's give it a try. I hope you can see it. So we are running 110 amps, so 20 amps short, and around 8.8 kilos. This is not 10. This is a test with a Dragonfly. Nope. 92 amps and only 8.5 kilos. No go. Okay, we got one more chance with the Mantis. This is from JP. This is 150 amps and this is a brand new one. So let's see if this one performs better. Or else I need to buy a new Schubler, or we need to swap them out with the version 1. Okay, save the best for last. I just welded the Hobby Wing 150 12S. Let's see how this will perform. Batteries are all charged, and of course, if you have questions, I did calibrate all ESCs. Let's try her. It was the ESC. Oh my god. It was the ESC. 10 kilos. Wow. We've got it. Yeah. From JP is the winner. Super happy. So we got 10 kilos of thrust. So this one provides, when the batteries are warm, slightly over 10 kilos, which is super happy according to the data sheet. The big loser are these fly collars, but acceptable because they can only go to 120, and according to the data sheet I need 130 amps. And the biggest loser for today, I'm sorry to say, but Castle Ice, you didn't perform. This is a 160, and I'm so sorry. I lose 2 kilos of thrust with this ESC. Calibrated, tested, I played with timings, I tried everything what I could do, but clearly with a big overwin, this JP programmable ESC 150. So we will build everything back in the Harrier model. And again, guys, make sure to subscribe, turn on that notification bell for next week's video. Cheers. So lots of learn, but I think this will be enough for this video, and maybe next week we're going to find out which setup works the best and bring her up in the air. So if you don't miss any new videos, make sure to subscribe and turn on that notification bell, and don't forget the thumbs up to push this video online. Guys, thank you for watching. See you next time.